Now, there are also rules. Rules are actually very, very similar to logic. And what rules are is they're basically if-then structures. And I will tell you that students tend to be confused the most by being able to tell the difference between a rule or logic, because there is overlap. Here's the big difference that you want to remember. Even though it's similar conditional logic, rules are more applicable to the real world. They are more generalizable. They are broader. They are applicable to the real world. Logic is not always applicable to the real world. So they can describe general information about the world. Students are overworked. If X is a student, F is overworked, just like logic. But you expand beyond that. You talk about how to do things. If you register early, then you will get the courses you want. It's much more real world. Linguistic regularities. If a sentence has a plural subject, then it has a plural verb. So again, we're talking about something that's really applicable to the real world. This would be more similar to the second part of our Watson task. First part, how applicable, if you're just using a bunch of numbers and letters, how applicable is that to the real world? Yeah, not so much. Remember, with rules, rules are applicable to the real world. Logic is not necessarily applicable to the real world. That's the difference. But if you think about it, as you take your programming classes, we use rules and we use logic a great deal. That's why they are considered to have really good representational power. And, some will argue, we do think about these things in this way a lot. Think about when you're trying to add a class. Right, when you're trying to get into a class, is it better for you to register early or late? Early, a real-world application. So, again, it represents real-world goals. And here's one other thing. You can simulate backwards reasoning. So let's take a look at an example of that. If you want to go home and you have the bus fare, then you can catch a bus. Makes sense, right? Now let's look at what we can do, that additional step that we can do with rules. You go home if you have the bus fare and you catch the bus. So again, it's applicable to the real world, and you can simulate backward reasoning. Keeping in mind that you do have to keep the meaning of it consistent. Now, I told you that we sometimes use these things when we're doing some coding in some of your classes, right? Well, sometimes I'll have students who will say, well, yeah, it's great for class, but you know, with code reuse and all those things, do we really use it extensively in any systems out in industry? The answer to that is actually yes. They tend to be very specific systems that are for very specific jobs or specific capabilities. So, it's widely used in expert systems. Who has heard of expert systems? Anyone want to take a guess as to what expert systems are? Anyone want to give me an example? You guys are brilliant, I'm telling you. That was my test to see if you are actually reading my slides. All right, so expert systems are basically systems that are designed and built for a very specific purpose, where they are used to help in things like decision making. They use rules so that it can highlight certain patterns, for example. So it's used extensively in financial systems. So you'll find some expert systems when you are doing stock trades. There are other expert systems that may, that may help flag a problem with a particular individual who's trying to get a loan, for example. It'll flag it so then a human can look at it. And increasingly, it's being used in medical diagnostics. So if you go into a hospital and let's say you get an MRI on your brain, and you see all the different slices. 10 years ago, basically, the doctor would just see the slices, and they have to go through all of them and look at them very carefully. With medical diagnostic systems, more and more, what they're doing is there are certain patterns that it will take this information and it will run it through these rules, run it through the patterns, and if there's something that looks suspicious, they will immediately alert the doctor. Now, it can't diagnose you. Some people will think, oh, I can just be diagnosed by a computer. It doesn't quite work that way. What it does is it helps go through these rules and highlight something that we as humans then want to go ahead and look at. And that is being used, as I said, more and more in medical diagnostics. So if any of you are interested in things like health informatics or going into the health field and dealing with technology, which is a growing area, by the way, this is something you would want to be quite familiar with.